Now that we've talked about different segments and circles and how to find their length, we're going to switch gears and bring it over to angles and then also talk about arcs, and we'll do a little bit of arc length too. So they all kind of work together. The two that we're going to work with today are central angles, and then we'll talk about their arcs and also arc length. So starting with central angle, well, we have two figures here. The first one is a central angle because the vertex is the center of the circle right there. Now this one here is not a central angle, so this is not a central angle. And the reason behind that is because this vertex right here is not the center of the circle. Now it is an angle, it is, it can happen inside of a circle, it's just not called a central angle. The key concept behind a central angle is that it will have the same degree measurement as the arc it forms. So if you wanted the measure of angle ABC, that would be the same as the measure of arc AC, and we're talking about degrees. The measure of angle ABD would give you arc AD here. CBD would give you arc CD here, and then ABD, which actually kind of has two different angles or arcs that are formed. So ABD, if you go around this way, could potentially give you arc AD in that direction. So I'm going to go ahead and throw that in there as well. So the measure of angle ABD would give you measure of arc AD. So that's one way, but this one in particular right here is asking specifically about all the way around here. So ABD going in the opposite direction, giving you the measure of arc AED going around in the other direction as well. The main idea behind all of this, is that all the central angles are going to add up to 360, as well as all of your arcs, which we all know because there's 360 degrees in a circle, and that's because of all of your central angles. So any angle here, 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 and then our last one there, all of it's kind of hard to do that one. All of those add up to 360 degrees, and then as well as all of the little individual arcs will add up to 360 degrees. So in these first examples here, what we're going to do is find the different arcs and angles based on the information that we have in this picture. So what I'm going to do first actually is take the information we have and label everything on the inside as much as I possibly can. So starting with the fact that this is a 90-degree angle, that would make this 45, well, since this is 45 here, then this would have to be 45 as well. RU is a diameter, so to get this angle in here, so from here to here, we're going to take 180 and subtract 45 from it, which gives us 135. So this angle right here is 135. And then to get this angle right here, we're going to take 180 and subtract 45 and also subtract 60 from it for a total of 75 degrees. So now that we have all the angles, we can actually get all of the arcs as well. So let's start with the measure of angle SCT. So SCT, starting at S, going to C, and then to D would be 75 degrees. And then it says the measure of the arc ST. So that would be this arc here. Well, any central angle is the same as the arc that it forms. So this is a 75-degree arc. There we go. SCU, so we're going from S to C all the way to U. So it's 75 plus 60. You have to add them together. So that is a 135-degree angle, which would make arc SU also 135, and that's because it's going from S to C and then all the way over to U. SCQ, now we already know that SCQ is a 90-degree angle because that is labeled right there, so that's 90. And then our last one is STQ, the arc. So arc STQ, and you're looking at it starts here and it goes all the way around the circle to Q. So we need to add all of these pieces together. So 135 plus 60 plus 75 for a total of 270 degrees. The last bit of this lesson would have to do with arcs and how to find arc length. So they have this a degree measurement, but they also have, oh sorry, a length, meaning if you could straighten them out, how long would they be? So remember, the degree measure is the rotation, and then length is how far apart your endpoints are. So this formula you're going to use every single time. You take the length of the arc and divide it by the circumference, and then you take the degree measurement of the arc and put it over 360. So for what I'm going to do, since we need the circumference for this, to do this, to find the arc length, I'm going to take the circumference, which is pi times the diameter, and the diameter is 24, so it is 24 pi. And I'm going to leave it like that. So to find the length, and since it says length here in the directions, that's how we know we're finding length of arc DE. Well, based on the fact they give you DOE is 120, that's this angle right here, is 120 degrees. So you take 120 and divide it by 360, and you set that equal to the arc length, so this is arc length, over the circumference, which is 24 pi. I'm going to cross multiply, so I get 360x equals, and now when I cross multiply here, I'm not actually going to multiply by pi, I'm just going to do 24 times 120 to get 2,880, and then put pi on at the end. Divide by 360 on both sides of your equation so that we can actually get our arc length. So when we enter this in the calculator, you can do that alpha y equals to pull up the actual fraction, so you make sure that you actually type things in correctly, but you can also just type it in as is and use the pi button, and we'll get 25.1. Second one is BAC, so we're looking for B to A and then all the way around to C. Well, one of the easiest ways to do that would be to find this arc length here. Nope, sorry. Find the arc length of this here, and we could subtract it, or you could just work your way around, which actually, now that I think about it, it might be easier to just work our way around the circle. So let's start with the fact that this is 120. Let's see, COB is 45 here. Since this is 90, this would be 90 here as well, and then that's 120, that's 45, so that's 165, so this little angle in here would be 15 degrees. So if we're going from B to A to C, we're doing everything except for this 45 degree angle right here. So the measure of that angle, that total all the way around, would be 360 minus 45. Nope. Yep, 360 minus 45. All right, so the angle that is formed is a total of 315. We put that over 360 and set that equal to x, which represents our arc length, so how long is that distance all the way around, and we put it over 24 pi. Now this one, for some reason, I didn't actually work it out, so this will work kind of nicely for you guys, that I can show you how to do this on the calculator and how to get this worked out correctly. So let's go ahead and let me just move this over. Remember, you want to cross multiply. So we're going to get 360 times x, but we're going to do 24. So 24 times 315 and push enter, and we get 7,560. So we get 360x equals 7,000, I already forgot what it was, 560. And then we also have the pi on the end. Now I'm going to divide by 360 on both sides. So what I'm going to do when I go over here and enter this in is I'm actually use the alpha y equals function and push enter, and so that I can actually type in 7560, and I'm going to use the pi button, so second and then that up arrow, that's where pi is, push the down arrow and type in 360. And we get 65.97. So 65.97, if we were rounding to the nearest tenth, sorry, I wanted to box that in, that would actually make this 66.0, because the 7 would round the 9 up, and that would automatically make it to the nearest tenth right there. All right, and then our last little bit, BAE. Well, if you're looking at arc BAE and BE is a diameter, well, BAE would be 180 degrees then, right? So you take your 180, put it over 360. Nope, I ran out of room, so I'm going to go ahead and take this stuff out then. So for number 3, you take your 180, you put it over 360, and you set that equal to x over 24 pi. Cross multiply to get 360x equals 4,320 pi. Divide by 360 and you will get 37.7 as your arc length. So again, when we're finding arc length, that's as if you are taking this distance. So how long, if you could take this piece all the way to this piece, that curved portion, and take it out and straighten it, how long would that piece be?